In this problem, we want to find all relative extremity of the function. So we got f of x is equal to 2x to the third minus 21x squared plus 60x plus 12. I know I'm going to need to do it eventually, so let me go enter this in my calculator. So I'm going to go to y equals, and I'll put that on y1. So we've got 2x to the third. So we got 2x caret 3. Now if you got a newer T84, you have to press your right arrow key to get out of exponent mode. Minus 21x squared plus 60x plus 12. Okay. Now to see if our table's set up correctly, do a second window. And you should have independent set to ask. If you don't, down arrow to that line, right arrow, put your flashing cursor on the ask and press enter one time. And then exit out by doing second mode. Okay. Well, now let's go through our steps. For the second derivative test, which is what I'll use, though I think first derivative test, what we did in previous lessons, is probably just as easy. We want to find our first derivative. Okay, so first derivative, f prime, take 2 carries out in front, x to the third, take your power, put it out in front, lower it by 1, minus 21 times x squared, take your power, put it out in front, lower it by 1, 60x becomes 60. So that gives us 6x squared minus 42x plus 60. Now step 2 says set equal to 0 and solve. These are our critical values. Now remember, if you have a fraction, you have to do more than that, but we got 6x squared minus 42x plus 60 equal to 0. We want to factor out GCF. I notice they're all divisible by 6. And that gives us x squared minus 7x plus 10 equal to 0. And then we'll factor using the PSD method. 6 carries down, and here we got x minus 2 times x minus 5 equal to 0. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I said x minus 2 equal to 0 and x minus 5 equal to 0. So that gives us x equals 2 and x is equal to 5. And these are our critical values. Okay, step 3, find the second derivative. So our first derivative was right here. So we're continuing taking derivative of that. So f double prime, 6 stays out in front, derivative of x squared, take your power, put it out in front, lower it by 1. Negative 42x just becomes negative 42, and 60 drops away. So that gives us 12x minus 42. Step 4, plug your critical values from step 2 into your second derivative. So we're going to take our critical values, which we said was 2, and we said was 5, and plug them into our second derivative. This right here. Well, I got 12 times 2 minus 42, which gives us 24 minus 42. Don't care what it really is, we're just looking to sign. You see where it says f double prime of c is less than 0? Then f of c is a relative max. This is less than 0. It's going to be negative. So this is going to be a relative max at x is equal to 2. Now for this one, I'm going to have 12 times 5 minus 42. 12 times 5 is 60, minus 42 is positive, which is greater than 0, which means it's a relative min. So relative min at x equals 5. Well, we also need our y parts. So we want to plug these values back into our original function, which is why I entered that in the first place. Back on our calculator, remember y equals, I put my original function in there. So now I'm going to do second graph. go in table mode. And if you have any numbers there, you can press delete to clear them out. And we want to put in 2 and 5. So 2 inner, 5 inner. Now 2 gives us 64, and 5 gives us 37. So our answer, we're going to have a relative max at 264, and we'll have a relative min at 537. And those would be our two answers using second derivative test.